Okay, now let's get into the API gateway. So at a high level, we know what a API gateway does. It exposes a REST API to our clients. So usually it will proxy a request to Lambda, but not only to the Lambda. And we have seen this lecture that how many proxy could be. And Lambda can do some create, read, update, delete, related operations on a DynamoDB table. So that is some very classic solution architecture that is serverless. Okay, but it can do so much more than that. But as in the general idea, we have our first point of contact with our client is going to be our Amazon API gateway. So what it would do, okay, it helps expose Lambda function, but not only, also HTTP endpoints and AWS services as an API. So, but why would you leverage an API gateway instead of just calling these things directly? Well, the API gateway gives you a lot of features that you may want if you are maintaining APIs at a scale. So the first one is API versioning. So you can publish multiple versions of your API, which is really helpful to make sure your clients can migrate from one version of API to another. As you add features, it gives you authorization. So we'll see the integration of security on that. Traffic management we have. So you can define API keys, usage, plan, and throttlings. You can get a huge scale. So the API gateway does scale very well. It's serverless, so you don't have to manage your own any server for these features. You can do some request and response transformation directly from the API gateway for some compatibility issues. For example, like you can publish an API as an open API spec, or import an API as an open API spec. So the idea here is that when you have an open API specification, your client can just generate a client library automatically for that specification and start using your API on the go. So which is a lot of time saved, and has support for CORS, cross-origin resource sharing, request sharing. Okay, so some limits to know right off the bat for the Amazon API gateway. When you think as a solution architect, it's the right thing for actually how you will be actually maintaining, deploying these things. So when you think as here, so number one is there is a 29-second timeout for the API gateway. So the most of the time what you may have seen that you are calling the Lambda function endpoint with the API gateway, and the 29-second timeout is of the API gateway. So maximum it can so the Lambda function, you are actually executing Lambda function for the minute. So in that case the API gateway is timed out, and you will not be receiving when the Lambda function is returning the results after the processing. It's not going to work out. So what you have to maintain in that case, that you have to run the Lambda function even just for the 29-second as of the API gateway timeout. So in such a case, that like even you could consider the actually provisioning an EC2 instance, that would take around 24 to 27 seconds to provision EC2 instance. And I'm not talking about like some micro instances, I'm talking about G4DN.X large instances. So here's what I'm saying, that 29 seconds is the timeout, and if you are running any request with the serverless or with the Lambda, then you have the limit up there also of the 29 seconds to return the request, return the response to this API gateway, so that the API gateway can return that response to the client. And so if you are proxying a request to a Lambda function, but the Lambda function, even though it has 15 minutes timeout, takes 3 minutes to process a request, your Amazon API gateway will time out before your Lambda function, because the timeout on any request on the API gateway is 29 seconds. So that is really important limit to know when you look at your solution architecture. The second thing is 10 megabyte max payload size. 10 megabyte is kind of good, and I'll be talking about it more, but the idea is that you cannot send more than 10 megabytes of data in one request through the Amazon API gateway. So again, if you are trying to upload big files onto whatever, maybe Amazon API gateway is not going to be the right thing for you. And it's super important to take into account these two limits when designing your solution architecture. Okay, so now Okay, so something we have already seen are the deployment stages. So the API changes are deployed to stages. Okay, we can have as many stages as we want, and you can name it however whatever you want. Okay, but as for the some of the conventional methods, for example, like dev, test, prod, staging, and so on. And these stages could be rollback as a history of the deployment is kept with the API gateway, and so you can roll back in previous stages in case your deployment was wrong. So it's really neat feature in case you something bad and want to go back in time. So we have seen how to deploy a stage and what it can be pointed to. So it can be pointed to a production alias, prod alias, or a test alias for your Lambda function, and these aliases can be pointing to v1, v2. So I'm not going to go over those all again of the Lambda things, but you remember this from some of the previous lecture of the Lambda. So next, for the integrations, so we have multiple type of integration. HTTP type integration, in case you have HTTP endpoint exposed in your backend. For example, you have an internal HTTP API on premise, okay, or you have an application load balancer and you want to add an API gateway in front of it. So actually, why would you even do this? Okay, why would you actually HTTP API on top of that you are putting here an API gateway? So why would you do such things? Maybe you want to add rate limiting, you want to add caching features, you want to add user authentication, you want to add API keys or something like etc. of the these are all the features of the API gateway. So these could be very good reasons to add an API gateway as an extra layer on the HTTP API on premise. So there are Lambda functions, they are very classic. We have seen it many times. So the API gateway will invoke a Lambda function, and it's very easy way to create a REST API that is backed by AWS Lambda. Okay, all is like the serverless in serverless fashion. It's here. So also it's very important. So this is something that's very prominent in the DevOps exam that still comes up in the solution architect professional exam also, that which is that you can expose a service specific API through the API gateway. So it's any API. So it's any API. So some very common use cases, for example, would be to start a step functions workflow or to post a message to SQS, simple queue service. But again, leveraging these features of authentication to deploy publicly, to have rate control and so on. So it is very common to have API gateway proxying and AWS service for a specific API. Now let's talk about directly one of these applications as a solution architecture discussion. So we want to have API gateway in front of S3 to upload a file. But the thing is, if you remember what I said in the beginning of this lecture, like there is a limit of 10 megabytes that you will be impacted with, 10 megabyte payload size limit. So let's have an example. We have the client application and we have an S3 bucket and it's private, and we want to allow users to upload files into S3. So one way is to do it would be say, okay, we have an API gateway and the API gateway is going to be proxy in front of the service S3 for the API put objects. So we can say, okay, I want to upload a file, and then API gateway with the proper configuration will upload that file into S3. But the limits here is that you cannot go over 10 megabytes of payload size. So if you want to upload a big file, you will run into here some of the issues of some of the issues. So this is not a perfect architecture, but it is possible architecture. Okay, and this is the kind of things you have to go and really look at when you go into the exam. Okay, now what is a better architecture? Well, we have same kind of things. The client application does talk to the API gateway because we like the features of the API gateway and says I want to upload a file. Now the API gateway will talk to a Lambda function, and the Lambda function can do something like it can generate a pre-signed URL from our S3 buckets, and what it does by getting this pre-signed URL is that it will return the URL itself, which is very light, and the real URL will be forwarded to our client application from the API gateway. and then using that pre-signed URL directly from our client application, we as you are not able to see, this is generated pre-signed URL is just available here and in that on that arrow. So then we are able to upload directly into S3 any file of any size we want. Okay, so this architecture is much better. Yes, there is an extra Lambda function, but it scales a lot better. There will be no any size limit, so it respects every component for what it's supposed to be doing, and using a pre-signed URL we can upload files of megabytes, gigabytes, or even the terabytes, so whatever we want. So that this is a much better solution architecture. Again, these two architectures work, it depends on what kind of limits you want to have, and again this is the kind of things that the exam will test you upon. Okay, now now the API gateway has different endpoint types. The first one is edge optimized, which is a default, which means that your requests are routed through the CloudFront edge locations. So that improves latencies, and that's really helpful when you have like global clients, but your API gateway, it still lives in only one region. Consider like US East 1 region or AP South East 1. And then you can deploy it also as the regional API gateway. So that means that all the clients are within the same region. Otherwise, like it would not make sense any. So you could manually combine this with the CloudFront if you want to have more control over the caching strategies, distribution, that kind of things. So by default is optimized. So is optimized API gateway endpoints type endpoints are the is optimized. But you can have a regional API gateway and combine this with the CloudFront. Finally, private, where you want to just deploy things only within your VPC and get access from the ENI, and you need to use a resource policy to define access to your private API gateway. So remember 3 different ways of deploying your API gateway: is optimized, regional, and private. Next, we have super important things that you can cache API responses from your API gateway. So why would you use the caching? Well, to reduce the number of calls made to the backend. So the idea is that your client talks to the API gateway, and your API gateway, before issuing a request to the backend, will check the gateway cache, and if it is available, if it is a cache hit, then cache it will return to the clients. Okay, otherwise it will do a query in the backend in case of the cache miss, if there's a cache miss, and store the results in the gateway cache again. So this is very helpful, and then your data in your cache has a TTL, time to live, which is default is going to be 300 seconds like 300 seconds. So around 5 minutes, yeah, it's 5 minutes, but you can set it to 0 if you don't want to cache it, or even it could 1 hour, it could go over the 1 hour if you want your data to be cached for a long time. So caches are defined per stage, and it's possible to override each cache settings per method. So if you have a I'm sorry for that. If you have a get on whatever URL, or a put in whatever URL, get request and put request on whatever URL, and you don't want it to cache for that thing, you can override the cache setting for these specific methods only. So the client themselves as well can invalidate the cache using a header called cache control, and max is equal to 0. You need the proper IAM authorizations to do this. But it's possible for the client to basically bypass the cache. You also have the ability to flush the entire cache, so it means invalidating it immediately. So if you wanted to repopulate the cache at any one point of time, finally the cache can be encrypted, and you can define a capacity of the cache between 0.5 gigabytes to 237 gigabytes. So it can be even go up to the quite big cache. Now in terms of errors, it's very important to understand the API gateway errors, because they indicate to you a lot of information. So in case you get a 4xx 400 error, for XX error. That means it's client errors. So examples, 400 is a bad request, 403 is access denied, or maybe your web application firewall WAF has filtered that request. 429 is for quota exceeded or throttling directly coming from the API gateway. And when you get actually a 5xx errors, that means it's a server side error. So some notable one is 502, means a bad gateway exception. That means usually when the Lambda function returns a bad output, or occasionally when you have out of order invocations due to heavy loads. You have 503, which is service unavailable exception. So this is when the backend cannot respond. And you have 504, which is integration failure. And one example is the limit. So I've been talking about in the beginning of this lecture that limit of the API gateway. So which is for the example when the endpoint request timed out, because the API gateway has a request timeout of about 29 seconds. So this is when you will get the 504 server error. Now next for security, so you can load SSL certificates onto your API gateway and then use Route 53 to define a CNAME. You can have resource policy, for example, like an S3 bucket policy. So this controls who can access the API, which accounts, which IP, which CIDR blocks, which VPC or VPC endpoints, and then IAM execution roles for the API gateway at the API level. For example, if your API gateway needs to invoke a Lambda function and you need to define an IAM roles for that, it supports CORS, cross-origin resource sharing. That means it gives you some browser-based request, some browser-based security, and it controls which domain can call your API. So if the client is using well-behaving related something situations. So this is CORS, cross-origin resource sharing. It's where like it's the time where the same origin policy relaxed, same origin policy remains relaxed. Now for the authentication, we have three ways. You have IAM based access. This is good when you want to provide access within your own infrastructure, and it uses the IAM credentials passed in the header through something called SIG-v4. If you are not able to see SIG-v4, okay, you have Lambda based authorizers, used to be known as custom authorizers. And this is when you want to use a Lambda function to verify a custom authentication token. Things like OAuth, SAML, or third-party authentication, and you have to program the Lambda function to verify the authentication mechanism. Or we can use like the deep integration with the Cognito user pool, in which case the client has to authenticate with the Cognito, and the client will pass in the authentication code token to the API gateway, and the API gateway knows out of the box how to verify that token. So what does it would like that with the client connecting to the Cognito user pool and authenticating, and then gets a token back, it passes the token to the API gateway, and the API gateway can verify that token with the Cognito user pool. Then if it does, it can invoke your Lambda function. If you are not able to see, this is passing identity, and this is one of the backend Lambda function. And then if it does, it can invoke your Lambda function, and it will pass the identity of the color to the Lambda function, pass the identity of the Cognito to the Lambda function. So you can do some extra logic on your Lambda function side. So the thing to notice here would be that your client has to first authenticate with Cognito user pool, and you need to program obviously for this and the right code. Finally, in terms of logging, monitoring, and tracing, that's very important. CloudWatch Logs does give you logging at the stage level for log level error or info. And you can log full request and responses data, so it can be quite helpful when you want to troubleshoot, and you can also send API gateways access logs, which is customizable, and the logs can be sent directly if you wanted to into the Kinesis data firehose, as an alternative to CloudWatch logs. You have CloudWatch metrics, where you get the metrics by stage, and you can enable detailed metrics, and you get some information such as the integration latency and the latency overall, the cache hit count and the cache miss count. All of these are very important to understand. And if you have optimized your API gateway the right way, then you have the finally the X-ray will give you the tracing to get extra information about the request going through the API gateway, such as latencies, errors, and so on. And if you have X-ray on the API gateway plus X-ray on the Lambda function, that will give you the entire picture of your architecture is working. So okay, so lots of good information. I hope you liked these. For some additional knowledge, I would take a little more of your time in this lecture. So the first one is around uses, plans, and API keys. API gateway, uses, plans, and API keys. So if you want to make an API available as an offering, maybe to sell it to your customers, then you should use a uses plan, which defines who can access one or more deployed API stages and methods, and how much and how fast and what rate they can access them. So for this, it will leverage API keys to identify API clients, and also also the meter. So it would measure the access of your APIs. Then within the usage plan, you can configure throttling limits, the quota limits that will be enforced on each and every individual clients. Now the API keys are going to be just a string value, and that you are going to distribute to your customers. That will uniquely identify them. For example, here is an access to, here is an API keys have been given as an example. Now you use this combinations with usage plans to control access to your APIs, and then the limits themselves will be applied at the API key level, and the quotas is the overall number of maximum requests within your API keys. So these two things together allow you to limit access and sell access to your API keys. The other thing around API gateway is Websocket API. So Websocket is a two-way interactive communication between the user's browser and the server. And the server has the possibility to push information to the client, which enables stateful application use cases. Now the website APIs are very helpful, because especially with real-time applications such as chat application, collaboration platforms, multiplayer games, and financial trading platforms. It works with the different AWS services such as Lambda or DynamoDB or even HTTP endpoints. So the architecture is so this example of the chat application has been given, and from my view it has been hidden the Lambda function on disconnect. That's not a problem. Okay, so here the architecture is as so the second example of the chat application. So the clients will connect to your API gateway through a persistent connection through the WebSocket API, and then the API gateway is going to invoke a Lambda function called onConnect. Maybe there will be there will persist the connection to the DynamoDB table. Then another Lambda function is called send message to send the message and parses that message into DynamoDB, and a Lambda function called onDisconnect, which will be invoked whenever the connection is disconnected. So when do you channel back replies on the client channel? So what would happen in such case? So we'll use something called added connections. So here is your WebSocket URL, okay, and then through this you are going to get a connection ID, which you going to persist in the DynamoDB table, and okay, and then for each connection you are going to get a connection URL callback, which leverages the added connections handle, and if you invoke that URL, so /added connections /connect /connection ID, then if your Lambda function is posting a message into this URL callback, which is on your API gateway, then the API gateway is smart, and I would say that, okay, I know I should send back message to my clients, and this is how WebSocket would work for the two-way communications. On the one way, it goes from the client to the API gateway and to Lambda function, and then the another way, anything that posts data into the special callback URL with the address connection will be able to send back to the desired clients. Okay, so this is all for the API gateway, and this was a little long lecture, and I hope you liked it, and I will see you in the next one.